Okay, so let's start by looking at the basic concept of these bounds and error intervals. So essentially the idea is in real life, most numbers are rounded, especially if it's continuous data. So what I mean by that is, as a quite common example, if you think about when Usain Bolt won the 100 meters in London back in 2012. He ran it in a very specific time. I can't remember off the top of my head exactly what it was. It's around about sort of 9.68 seconds. But obviously, that number has been rounded in some way. That wasn't the exact time that he ran it in. So then the question is, right, well, what was the maximum possible time that he ran it in, and what was the minimum possible time that he would have ran it in if it was rounded to two decimal places or three decimal places or whatever it was? So let's look at a really basic example to start with, and we're going to keep the number the same all the way throughout, but we're just going to change how it was rounded and then see what happens to the error interval, to the bounds in each scenario. So we've got the number 500, and first of all, it's been rounded to the nearest 100. So what I'm first of all going to do in the middle of my number line here is I'm going to put that starting number 500. And it's been rounded to the nearest 100, so to the right of this, let's add 100 on, and let's take 100 away. And then what we're going to do is just experiment. We're just going to move along the number line and just simply see which 100 we're closest to, because it's been rounded to the nearest 100. So let's say that we are somewhere around about here on, let's call it 520. Now, of course, if you've got the number 520, you round that to the nearest 100, you're going to be closer to 500 than 600. And you can see that on the number line. We're definitely slightly closer to 500 than the 600. But what about if we were to go up here? Let's say that we're now on the number 580. Now, of course, from there you can see we're now much closer to the 600 than the 500. And it makes sense when you look at the numbers. If you round 580 to the nearest 100, you are on 600. So there must be some sort of midpoint between the 500 and 600 where it crosses over. So there must be some sort of point, some sort of number where it goes from being closer to 500 to being closer to 600. And of course, it's right in the middle. And what's right in the middle of 500 and 600? Well, of course, it is 550. So what we mean by that is if we go slightly left of 550, we will be closer to 500. If we go slightly to the right of it, we will be closer to 600. And exactly the same is true on the other side when we start to look between the 400 and the 500. Right in the middle is where this crossover point happens. And right in the middle there is going to be 450. So we've got these 2 points now. And these are known as our upper and lower bounds. So now the question is, how do you take these bounds and write them as an error interval? And that simply means the error in the rounding that's happened here. All that you actually need to do is very simple from here. You've basically done all of the hard work. You take your two numbers, so let's start with the smallest one, and we're going to say that our original number, let's call it x for argument's sake. You normally always use a letter there. So x would have to be greater than the 450, but it would have to be less than the 550. But if you look closely at the inequality symbol that I used on the left here, it does have the little underlining bit, which means it can be equal to the 450, but on the right-hand side, it doesn't have it, which means it can't be equal to the 550. And if you think that makes sense, think about how you round numbers. If you're on the number 550 and you're rounding to the nearest 100, the way that basic rounding works is you would round that up. So 550, we cannot actually be equal to that. If we were equal to 550 and we rounded to the nearest 100, we wouldn't get 500, we'd get 600. So it has to be everything less than 550, but it can be equal to the 450. If you're on 450 and you round to nearest 100, that will give you 500. Let's have a look at the next ones as well, because it works in a very similar way. This time, I'm going to start the same way. We're going to put 500 in the middle of our number line here, and then to the right, I'm going to put 510, and to the left, I'm going to put 490. Of course, that's because we're rounding this time to the nearest 10. And then same idea again, what number is right in the middle of those numbers? So between 500 and 510, of course, it's 505. And in between the 490 and the 500, that is just going to be 495. Just show that's right in the middle there. And then exactly the same as before, we're actually going to write down what the error interval would be. So we take our upper and lower bounds, and we put them in the same inequality again. Exactly the same idea. If it was equal to 505 and we rounded to the nearest 10, that would give us 510. So it can't be equal to that. It has to be less than that. It has to round to 500. But with the 495, if we were equal to that, then it would round up to 500, which is what we're after. Any number in between that upper and lower bound will definitely round to 500 when rounded to the nearest 10. Same again, starting with the original number, 500. This time we're rounding to the nearest whole number. So let's just add a 1 on and take 1 away. Same idea, what is right in the middle of those numbers? Well, in between 500 and 501, it's going to be 500.5. And in between 499 and 500, it's going to be 499.5. So it is possible to get decimal numbers with your bounds. That's absolutely fine. Same as before, put them in the inequality. And you've got your error interval for that one. The final one that we've got here is just using a slightly different way to round numbers. So we started off with some basic ways that we round numbers: nearest 100, nearest 10, nearest whole number. They can ask you to do it to decimal places. They can also ask you to do it to significant figures, which for me personally, and what I find most of the time with my students, is the slightly trickier way to do it. Same idea though. Let's start by putting the 500 in the middle. And then all that we're actually going to do is think about which digit there is the second significant figure. So remember how significant figures work. First significant figure is the first non-zero digit. First non-zero digit that I have here is the 5, and then everything after that is significant. So I'm going to draw a little arrow pointing to my second significant figure. And then we just think about what place value or what column that's in. So we start off in the hundreds. That 0 that we're pointing to, though, must be in the tens column. So in other words, this has been rounded to the nearest 10. So all that we need to do to actually work with exactly what we had earlier on. Two significant figures is actually the same as rounding to the nearest 10 here. And then same idea, go in the middle on both sides. And then take those numbers and put them in your error interval. So it can be equal to the 495, can't be equal to the 505. And that letter that we're using, X there, normally in an exam, they would actually give you the letter to use, or they would actually write it out and you would just fill in the upper and lower bound on the left and the right of it.